Welcome to OwlsPrep. This is CIE 9709, A-Level Maths, Paper 1, Topic 1.1 Quadratics. Throw a ball and the path it traces is a parabola. Ask a business where its profit peaks, and the answer sits at the top of one. This lesson is the algebra of that U-shaped curve, its turning point, its roots, and where a straight line cuts across it. Let's dive in. Start with completing the square. Any quadratic, ax squared plus bx plus c, can be rewritten in the form a times x minus h, all squared, plus k. Why bother? Because in this form the variable x appears in exactly one place, inside that bracket. A square is never negative, so a times x minus h squared is at its smallest, 0, exactly when x equals h. That single fact hands you the vertex. The turning point sits at x equals h, y equals k, with no graphing needed. Take x squared minus 6x plus 5. Have the coefficient of x, that's minus 3, and write x minus 3 squared, which expands to x squared minus 6x plus 9. That's 9 too many, so subtract 9 and keep the plus 5x minus 3 squared, minus 4. The vertex is at 3, minus 4. And one basic fact you'll lean on throughout. The sign of a, the coefficient of x squared, sets which way the parabola opens. A greater than 0 opens upward, a U shape, so the vertex is the minimum. A less than 0 opens downward, an upside down U, so the vertex is the maximum. Here is 1, positive, so it opens up and that vertex really is the lowest point. Now solve quadratic equations. Find where the quadratic equals 0, the x values where the parabola crosses the x-axis. These are the roots. There are 3 standard methods. Factorizing is fastest when it works. Write the quadratic as 2 brackets and set each to 0. The quadratic formula, x equals minus b, plus or minus the root of b squared minus 4ac, all over 2, works for every quadratic, whether it factorizes or not. And completing the square, which we just did, gives exact answers in surd form. There are 3 routes to the same roots, so pick the cheapest for the quadratic in front of you. 4x squared minus 2x minus 3. Factorizing gives x minus 3 times x plus 1. So the roots are x equals 3 and x equals minus 1, exactly where the graph crosses the axis. The formula gives the same thing. With a equals 1, b equals minus 2, c equals minus 3, b squared minus 4ac is 4 plus 12, which is 16. The square root of 16 is 4, so x equals 2 plus or minus 4, over 2, 3 or minus 1, matching the factorizing exactly. Before you solve, you can often ask a simpler question. How many real roots are there at all? The answer is inside the quadratic formula, under the square root, b squared minus 4ac. We call it the discriminant. If it's positive, the square root gives 2 different values, so 2 distinct real roots, and the parabola crosses the axis twice. If it's 0, the plus or minus adds nothing, so the 2 roots collapse into a single repeated root, and the parabola just touches the axis. And if it's negative, there's no real square root, so no real roots, and the parabola misses the axis completely. So the sign of one number tells you the whole picture before any solving. Here's the classic use. For what value of k does x squared plus kx plus 9 have a repeated root? A repeated root means the discriminant is 0, so k squared minus 36 equals 0, and k is plus or minus 6. A quadratic inequality asks not where the quadratic is 0, but where it's positive or negative, above or below the x-axis. The key idea is that a quadratic changes sign only at its roots, so you find the roots first, then read the sign off the shape. Solve x squared minus x minus 6 less than 0. Factorize x minus 3 times x plus 2, so the roots are minus 2 and 3. Because the coefficient of x squared is positive, the parabola opens upward, a U shape, so it dips below the axis between the roots and sits above it outside them. We want where it's below 0, so the solution is the inside. Minus 2 less than x less than 3. Always sketch the U, or the upside down U if it opens downward, first. The shape, not a memorized rule, tells you whether you want the region between the roots or outside them. Next, two equations at once, where one is linear and one is quadratic. Notice the quadratic here has two unknowns, x and y. The method is substitution. Make one variable the subject of the linear equation and put it into the quadratic. Here's the key step. After substituting, the whole pair collapses into a single quadratic in one variable, exactly the kind we've been solving all along. Take x plus y plus 1 equals 0 together with x squared plus y squared equals 25. From the linear equation, y equals minus x minus 1. Substitute x squared plus minus x minus 1 squared equals 25, which tidies to x squared plus x minus 12 equals 0, a plain one-variable quadratic. Solve it the usual way: x equals minus 4 or x equals 3. Now put each back into the linear equation, the simpler one, to get its partner. Minus 4 gives y equals 3, and 3 gives y equals minus 4. So the two solutions are minus 4, 3, and 3, minus 4. Keep each x with the y it produced. Don't cross them over. Here's a very common use of the discriminant. How many times does a line meet a curve? Substitute again. Put the line into the curve to get a single quadratic, and its discriminant tells you the number of intersections. If it's positive, the line crosses the curve at 2 points. If it's 0, the line just touches the curve, it's a tangent. And if it's negative, the line misses completely. The exam favorite is tangency. For example, for what value of k is the line y equals x plus k a tangent to the curve y equals x squared plus 5x plus 2? Substitute, and it tidies to x squared plus 4x plus, bracket, 2 minus k equals 0. Tangent means the discriminant is 0, so 16 minus 4 times, bracket, 2 minus k equals 0, which gives k equals minus 2. So whenever a question says the word tangent and asks you to find a value, it almost always means one thing: set the discriminant to 0. Last, a pattern worth recognizing. Some equations aren't quadratic in x, but they are quadratic in some function of x. Look at x to the fourth minus 5x squared plus 4. It isn't a quadratic, but if you look at x squared as a single object, it is. It's that object squared minus 5 of it plus 4. So substitute u equals x squared. The equation becomes u squared minus 5u plus 4 equals 0, an ordinary quadratic, which factorizes to u minus 1 times u minus 4. So u is 1 or 4. Now convert back, because we want x, not u. X squared equals 1 gives x equals plus or minus 1, and x squared equals 4 gives x equals plus or minus 2 for solutions. Two cautions. Solving for u is only halfway. You must return to x, and watch the range of your substitution. In 6x plus root x minus 1, put u equals root x, and you'll get u equals 1/3 or minus 1/2. But root x can't be negative, so you reject minus 1/2. That leaves u equals 1/3, so root x equals 1/3. Squaring both sides to convert back to x gives x equals 1/9. The same idea works when the hidden function is something else, like a tangent. So that's topic 1.1, Quadratics, 7 key points. 1. Complete the square to read the vertex straight off. 2. Solve equations by factorizing the formula or completing the square. 3. Let the discriminant be squared minus 4ac. Count the real roots before you solve. Positive gives 2, 0 gives 1 repeated, negative gives none. 4. For an inequality, find the roots, then read the sign from the U or inverted U shape. 5. Solve a line and quadratic pair by substituting the linear equation into the quadratic. 6. To see how a line meets a curve, substitute and let the discriminant count the intersections. 0 means the line is a tangent. And 7. Spot a disguised quadratic, substitute for the hidden function, solve, and convert back. Master these, and much of the rest of paper 1 leans on them. Next up is topic 1.2, functions. See you at OwlsPrep.com.